We are Team ENVE7 with the Lockwood Matthews Mansion parking lot redesign and water main replacement, sponsored by Ty & Bond and the University of Connecticut Department of Civil and Environmental Engineering. Our overall site includes 4 buildings, a center for printmaking, public restrooms, cultural alliance, and the Matthews Mansion. We're redesigning the parking lot in the red square, putting in a water main, and adding a bioretention basin for stormwater. The existing main is 6 inches, which is too large. It includes 2 hydrants and 2 separate service line connections, a 2-inch to the mansion and a 2-inch to the printmaking center and the cultural alliance. The detention time is 2 to 4 weeks, resulting in biofilm buildup. In order to size the water main, we used regulations from the Department of Public Health drinking water section and guidance from the American Water Works Association's M22 sizing for water service lines manual. The design constraints for the site include that we must maintain fire service and utilize the Butler Street connection instead of the West Avenue main connection, as well as not disturb the historic wall on Butler Street. The new meter location is shown in the top right corner connecting to Butler Street in front of the Stepping Stones Children's Museum. Our design allows for a 2-inch service line that goes up next to the parking lot and connects to the 4 buildings, utilizing the existing service line connection locations.
For the parking lot, the Norwalk Drainage Manual requires post-development runoff rates to be equal or less than pre-existing conditions for the given storm frequencies. To find the pre-existing peak runoff, we need to define the site drainage area, rainfall data, and soil data. The existing drainage area is seen on the right. The design point is where the runoff goes to and where we will place the new basin. For the rainfall data, we used NOAA data, and for soil, we used NRCS Web Soil Survey. The soil data said our soil is type D, which has a slow infiltration rate. Using HydroCAD, we got the peak flow rates for the site as seen on the right. Here on the left, we can see the existing parking lot and the asphalt to be removed in yellow. In the middle is the new layout, which includes handicap parking, a hammerhead truck turnaround, and the new basin in red. For the turnaround, we considered a loop turnaround, but it required more area and was more expensive. Here on the left is our new grading plan for the site, and in the top right is a more detailed drainage plan, and the bottom left is erosion control for during construction. After development, we analyzed the basin to ensure new runoff rates were equal to or less than pre-existing levels, and they are, as seen on the right.
So for the best management practice to handle stormwater, we chose a bioretention basin. We looked at other options to handle the stormwater, such as wetlands or swales. However, bioretention basins look the best in terms of size, were a good size, and did a good job of removing contaminants from stormwater. So in deciding and designing the bioretention basin, we looked at used a few different manuals, such as the City of Norwalk Drainage Manual, the Connecticut Stormwater Guide. The North Carolina BMP manual was used for the underdrains, and the other ones we used as well for the other parts. So for drainage, we have an underdrain, which is 6-inch PVC pipe with caps at the end in order to clean out the pipes in case there's any clogging. In the middle, we have a catch basin, which is a type CL to the CT DOT specifications, and from coming out of it is a 12-inch pipe that connects to an existing catch basin in order to drain excess water. So for the different layers, we have a 3-inch mulch layer. We have bioretention soil in the middle for getting rid of contaminants and drainage and infiltration. There's pea gravel, which helps trap any type of things that's coming towards the underdrains. And then we have type number 57 stone. For vegetation, we have 4 different types of plants that all look good and are native to Connecticut. And then we have opinion of probable cost, which we looked at all the different parts of the bioretention basin, the parking lot and the water main, added up all the prices, and the total project costs around $340,000. This is the end of the presentation. Thank you very much for watching.